Hello, my name is Andrei. Welcome back. Today we'll dive into TensorFlow.js Microservice implementation. Yes, you can run TensorFlow.js not only in browser, but you could also run TensorFlow.js on the backend on top of Node.js. So this is what we'll do, and I'll show how you could run TensorFlow.js on top of our open source Skipper infrastructure. So let's see how it works. Okay, so this is the brief architecture of Skipper, our open source infrastructure to run microservices and ML microservices on Docker and on Kubernetes. So it's built with Python, but we also support any kind of languages. Containers, microservices can be different technology, anything, because we use RabbitMQ for microservice communication, and RabbitMQ API is available in different languages. One of them is JavaScript. And because TensorFlow.js is emerging and popular framework basically for ML models implementation, we decided to add API support for Node.js based containers out of the box available in Skipper, and this allows out of the box to run TensorFlow.js workloads. So we created one of the services under services package here, which is called MobileNet service. And this MobileNet service is basically blueprint implementation for microservice which runs TensorFlow.js. And in my next video, I'll explain how you could Dockerize this container and how you could run it on Kubernetes with TensorFlow.js. Okay, so let's jump into the source code, and I'll explain everything step by step. So first of all, let's look into the structure. So this is the MobileNet service. In the root folder, we have package JSON, package.json. Basically, I was using npm init command to initialize this package with empty package JSON. Then we have src folder where we have the main.js, which acts as main entry script into our microservice. And then there's in app folder, we have MobileNet service script, which implements actual logic. And functions from this script are callable from main.js. And if you look into the package JSON, we see that our service is initialized with multiple libraries. One of them is Skipper Lib JS. So this is our helper library that we created and is published on npm. You install it with npm install at Katana ML Skipper Lib JS. And this library provides wrapper and helper methods to interact with RabbitMQ. So this library is using RabbitMQ API, but it makes it more generic. And in case if you would like in the future to replace RabbitMQ with something else in Skipper infrastructure, like with Kafka, then you don't need to go into each container and replace the RabbitMQ API. You could do it in a single place in Skipper library. So this just improves the maintenance. Okay, we also have TensorFlow.js Node packages being installed, which allows us to run TensorFlow.js on the backend. And TensorFlow.js Node, it runs TensorFlow C++ executables wrapped with JavaScript. So in terms of the performance, TensorFlow.js Node runs very fast and it's very stable. So it's great, and it makes it possible to use for any production use cases. And then we also installed MobileNet from TensorFlow package that is suitable to run with TensorFlow.js just for demonstration purposes. Okay, and this main.js is like an entry script. When this microservice starts, then main.js script is being started. And here we call event receiver from Skipper Lib JS, and we register with RabbitMQ to listen for the events that will be delivered to this MobileNet microservice. And whenever event comes, this event receiver will get the event, and it will call this method, event receiver on request. right? And event, and this will at the end will call from MobileNet service. It will call this method, call method, and this method will be responsible to handle the event. Okay, and from in Skipper Lib JS, you'll find this is another folder over here, Skipper Lib JS, and it's, as I mentioned before, this is the generic library which is published on npm, and you can install it in standard way. It implements two scripts, event receiver and event producer, and those two scripts, they help to interact and wrap complexity of RabbitMQ API. And you, for example, we catch errors. If there are any errors during event communication, we handle them and return user-friendly response and so on. So for MobileNet, when event is being received, MobileNet service class is handling the event call function. Over here, we are parsing data which is being transferred to us. And by the way, in our case, this is the Node.js based microservice, but event to this microservice is coming from another microservice from Python microservice, which runs fast API Python framework, which handles requests from REST service, gets this request, gets the data, everything is done in Python, and from there it sends the event to RabbitMQ. RabbitMQ gets this event and it distributes the event to the JavaScript microservice. So in Skipper, we basically already running containers with different technologies, like with Python and JavaScript. Okay, so we get the data, print it out, and then we call another helper method, run MobileNet. And just for demonstration, for test purpose, we also not only receiving event in this TensorFlow.js microservice, we are also producing another event so that another container would handle this event, do some job and return it back. And we're just calling another container. For example, here we're producing event, and we are sending data to Skipper data queue, and this Skipper data queue is handled by Python-based microservice, which is processing the data and returning back the result. We are not using this data which was produced in this microservice because we are doing a call just for test purpose to see that we can send event from Node.js microservice which runs with TensorFlow.js, and it works fine. And if you look into the run MobileNet helper method, over here we're actually loading a sample image from file. This is the image. Okay, it's not displayed. Okay, it's displayed as orange. We're loading the orange. Then we're using a TensorFlow.js helper method decode image. This allows to get this image in a format that we can submit to TensorFlow.js for classification for MobileNet model. Then we load MobileNet model, call classify, and print out the results, and it works great. So we can do a quick test. For example, if we open command prompt over here and we go to the main backend API, which is exposed by this sample Skipper instance, there is one endpoint for MobileNet. We do a call. It's successful, and then we can see in the log that image was classified by MobileNet, and we get 98% probability that MobileNet thinks this is the orange in image, which is correct. Okay, so thanks for watching, and my point here was to show and explain that it's possible to run TensorFlow.js on Node, and the main goal actually to provide you a blueprint application with sample code and as part of the Skipper infrastructure, which you could use and build your own microservice with TensorFlow.js, which could handle on the backend model training or model or prediction based on the model, different use cases. So thanks for watching, and for the next video I'll explain how you could take this microservice that you saw today and how you could create a Docker container with this microservice, and then how you could run it on Kubernetes infrastructure. So thanks for watching, and see you next time. Bye.